Today I'm going to try to convince you about some, or at least put some quantitative estimates around the different issues that our previous speakers have already brought up in this session. And I call this the price of fairness, a little bit of tongue-in-cheek, and the title is empirical characterization of algorithmic fairness for clinical risk prediction models, which is a URL to a paper that I'll share during the talk. So starting with acknowledgements, this is the team that makes it all happen. The two people circled in red are the ones who did the research. One of them I know is on the live stream, Stephen Fole. He's the one in the front row, and funding that keeps all of this going. So we've been talking about risk prediction and fairness quite a bit across this conference. And so I'm not going to go too much into the details here. The big point I want to make is that risk prediction, and I put prediction in sneer quotes because it's sometimes it's classification, but it's masquerading as prediction. It's often used to decide whether to act or not. So we saw a few imaging examples. I have one around a simple one, the ASCVD risk scoring. Ziad's work was already mentioned, Impact Pro algorithm for being high cost and the issues in using a wrong surrogate label and so on. So there's something like 250,000 publications for clinical risk scoring in PubMed, and that's still 2015. And since 2015 to now, God knows how many that is, definitely more than 300,000, I would imagine. And algorithms leading to unfairness are often a topic in the media. And there was this huge outcry after Ziad's paper, and on a periodic cadence, a new algorithm is found to be systematically biased, and there's an outcry around it. But what I want to focus on is the separation between these two core issues when we talk about fairness. There's one thing to strive for absence of systematic error in the estimate of a chosen outcome. So the probability that someone will have a cardiovascular event or so on, and how you find, which is the choice of the label. And then there's the related issue of having an absence in systematic error in assignment of some benefit, the enrollment into some risk reduction program, the prescription of a drug, or what have you. And I would submit to you that usually the outrage we feel is because of a systematic error in the assignment of the benefit. And the assumption, and often unstated, is that if we fix the systematic error in the estimate of the outcome or the biases in the labels and so on, that will fix the systematic error in benefit assignment. And I think two of our speakers have already alluded that that might be a little bit visual thinking. Unless we understand the causal pathways or the assumptions that we're making, we may or may not get there. So it's not that much of a convincing after having this nice intros. So there's this notion of algorithmic fairness. You can think about it at the group level or the individual level. I'm not going to talk about the individual level because it's very hard to formalize that. At the group level, the general idea is to prevent systematic error in the probability estimate given some protected attribute like age or sex or race or ethnicity. And there's some common constructs such as demographic parity in your model's output, or equalized odds, equal opportunity, having equal calibration. Each of these different constructs capture some different intuition about what it means to be fair. And then there are the criteria that declare the mathematical formalism that tells you which quantity should you equalize for your model to be considered fair according to that given construct. And then a corresponding metric that would tell us how much or to what extent has the fairness criteria be satisfied. And there's the huge body of literature around all of these things. I'm just establishing a framework that I'll use in the next slide. So this is the experiment that we did, this empirical characterization. On the left is we have a few data sets. So we use 3 data sets. Then we define between 3 to 5 outcomes on a particular data set. And then for those outcomes, there might be the sensitive attributes. So in this case, for the 30-day readmission, there is sex, race and ethnicity, and age group are the sensitive attributes. And then we have the model performance metrics, which is how good or bad the model is in terms of its predictive accuracy. The fairness metrics that tell us how fair, to what extent have we accomplished fairness. The columns would be the criteria by which we assess fairness. And we had 5 performance metrics, 8 fairness criteria, and 8 fairness metrics and 6 fairness criteria. So if I showed you the full figures, it would be, for a given data set, for a given outcome, you would see 2 panels with 6 columns and 5 or 8 rows, which would be too much to put on a PowerPoint slide. So we're going to zoom into a smaller fraction of that. And this particular URL, which is in the title, has the details of the empirical experiment that I just laid out. So on the right of this screen right now are the fairness metrics. So those are the rows, and the columns are the criteria by which we accomplish fairness. So the 3 columns are, we will be penalizing the difference in mean predictions across groups. We can do that penalization condition on outcomes, or just conditioned on or just within the positive class. So those are the 3 columns. We're looking at 30-day readmissions in one of the data sets, the STAR data sets, and the sensitive attributes being race in this case. For each panel, the x-axis going left to right is the degree to which you're jacking up your penalty, for in case the penalizing the differences in mean across groups, for example. And then the rows are telling us to what extent we're being successful or not. So the good news, which I'll just highlight in a second, is that these approaches seem to be doing what they're supposed to be doing. So if you look at the fairness metric of mean difference amongst the predictions by groups, and you're penalizing having a difference in the mean prediction, and as you jack up the penalty, the differences in means go away. That's this upper left blue box, and the other 2 similar like that. Okay, so that's the good news. The bad news is when we look at the performance metrics, and the columns are still the same. We're applying the same kinds of penalties, and from left to right, the penalty is going up. But now we're looking at AUROC, the average precision, and the average calibration errors. And as you can see, as we go from left to right, the average precision and AUROC drops as we start penalizing these various quantities. And then average calibration, if we're penalizing differences in means across groups, conditioning on outcomes or within the positive class, we get out of calibration really fast. So essentially, we're making the model systematically worse, mostly for everybody, except for these few rare cases where my mouse cursor is, where the orange line is going above the dashed lines. The dashed lines are the best you can do for a group. And so above that is good, below that is bad for the first 2 plots. So where do we go from here? So the bottom line, at least when we looked at all of these metrics across all of these outcomes, not only are we seeing this behavior, but the behavior is also quite unstable and depends on the definition of your outcome and the particular data set that you use. So that's the other piece of bad news. And so what we think is, and as the prior speakers have alluded to, we need a broader vocabulary for fairness. And these metrics are typically evaluated in a prediction setting using some older observational data. And we do not know why we observe the differences across groups. And our second speaker talked about the need for having some causal model at the back of your head. And we also do not know the effect of the model-guided interventions on the benefit accrued, which is the systematic error we want to fix. So more at this URL. And I'll close with sort of our current thoughts, which are not that contrarian anymore given the conversation, is that we need to incorporate perspectives from diverse stakeholders at the design stage. So that's been said like 3 times already. And we should probably be using fairness metrics for auditing rather than optimizing specifically against one formulation or another, or for one formulation or another. And then I think we need to worry more about the effects of the policies and the interventions that are being done based on these models rather than the predictive performance per se of a fair or a regularly trained model. So I think that with that, I'll close. And I think that's the last slide. Thank you.